Well, here we are with our second lecture on prairies and grasslands, looking at how they've been degraded and then how we restore them. Our second lecture of the day. So last time we were talking about what the major factors are that naturally structure these ecosystems, and of course we'll need to keep those in mind as we're restoring them. And what are those again? You're exactly right. Great job. High fertility due to the below ground biomass. Fire because of the low precipitation and open prairie exposure to those storms. And then grazers, like grasslands all across the planet. There are large herbivores that roam and would naturally be feeding on these grasslands. All right, so let's get into why are grasslands important. So taking it from an ecosystem services perspective, once again, I've used that analogy the other day of wetlands as the sort of the kidneys of our waterways. But it starts even before the wetlands, right? Wherever it rains, the ecosystems there are going to be able to clean that water, to filter that out. And so if the grasslands of the Great Plains can remain intact, it's estimated that we could reduce loss of 46 million tons of sediment. And remember, sediment loss is a problem not just because it gets into our rivers and streams and causes pollution there, but of course that's the topsoil of our important agricultural regions as well. So that kind of erosion is a huge negative impact on both fronts. In addition to the sediment itself, 87 million pounds of phosphorus and 427 million pounds of nitrogen. These are all chemicals that are going to be absorbed and incorporated into these plants, but again, they'll get washed down into our waterways and contribute to pollution issues if not. So another filter on our landscape. So I'm going to share a couple examples in this lecture from the SNEED Environmental Research Area and Prairie Restoration Project at Austin College in North Texas, where I taught for 1 year. And when I went to look this up, I went to the Austin College webpage, and wouldn't you know it, this restoration project is the Texas Commission on Environmental Quality's 2020 Environmental Excellence Award winner in the education category. So that was kind of cool. If you look a little more closely, you can also see that and in North Texas as well, remote learning has been extended to the end of the semester due to coronavirus. So we're all in this together, all across the country and the world. And one of the neat demonstrations they have at this restoration site is they have two containers of soil on the left and right of the student volunteer there. And if you can notice on the college students left, our right, there is a container with lots of intact prairie grasses. Whereas on the other side, there isn't. There's some small grasses, there's a shrub. And so what they do is they pour water onto the soil. And what's kind of cool is that a certain amount of the water runs off in that top spigot. That's the surface runoff. And then the other fraction of water percolates through the soil and gets poured out at the bottom of this little demonstration thing. And so it's pretty cool to see the different kinds of water that come through those different ecosystems, and that when you look at the water after it's been poured onto the soil that does not have the native grassland, looks kind of like this. Pretty nasty. So the idea just being that there's a lot of soil that gets moved out of these ecosystems when they don't have the native grasses on it anymore, whereas it's pretty much clear water that comes through it otherwise, right? They have those roots that hold the sediment together in the natural grasses. So a kind of cool little demonstration. So as well, right, we're talking about climate change mitigation, and it's always important to think of the roles ecosystems play there. And we talked about how important certain coastal wetlands are for accumulating carbon below ground, but in fact, the ecosystems with the overall highest rate of below ground carbon accumulation are, you guessed it, grasslands, right? And so, this is because once that carbon is stored underground, it's not going to decompose. It's going to stay there. It's because of these root systems. Again, when you look at this cross-section of soil, it's just so clear how much carbon is stored below ground. And it's incredible, right? So these plants are taking CO2 out of the atmosphere, turning it into plant biomass. Because they're perennials, they may die back every year, but they're constantly building that root biomass. And so they're constantly moving carbon underground. This is data from a study where they converted row crop agriculture to grasslands that were grazed, so pasture land that they were still able to have some agricultural productivity from livestock. And so you can see, moving from 0 to 6 years since conversion, you can see that very soon it was sequestering about 4 times the amount of soil underground as had been there in a row crop agriculture system. So again, there's potential to move a lot of carbon from above to below ground if we can restore these natural grasslands with their native species with a massive below ground root biomass. And this is something that's being done on pretty large agricultural scales. This is a tillage radish that's used to put, it's essentially a cover crop, right? Where that tuber is moving carbohydrates underground, and this is being used on an industrial scale by farmers to naturally start putting nutrients back into the soil. Just to give you a little bit of math, so in 2007 on this particular plot of land from 12,000 acres, it took almost 7,000 tons of CO2 out of the atmosphere. That's the same amount stored in 7,300 acres of forest, right? So you think of the woody biomass that's stored in. It gives you some idea of how fast some of these plants can move carbon underground. So definitely some climate change mitigation strategies that can be involved in our restoration practices here. All right, so how have these grasslands been created? Well, I think you could have probably answered this question from looking at the areas of the country where grasslands occur and realizing that what we have there now is agriculture, right? So this is county by county, the percentage of land that's being farmed. And so you can see that darkest green, that band from North Texas all the way on up into the Dakotas. Those are counties where 90% of the land is being farmed, right? So in all these areas, those grasslands have been turned into agricultural fields, and so there's this transition from perennial plants that are holding the soil together and moving carbon underground to annual plants with much shallower root systems, often with a fair amount of plowing to break those root systems up, and so of course a net loss of nutrients and soil and all kinds of things. And in case you're curious, the number on the bottom there, about 40% of the U.S.'s land surface is devoted to farms. Pretty intense agriculture footprint, the plow print, as they say. All right, so how do we restore grasslands then? So for the most part, we're talking about restoring agricultural land to native grasslands. So there's three steps, and I think this applies to a lot of our restoration scenarios, right? The first thing we have to do is remove the stressor, remove the activity that's caused it to be degraded in the first place. Then we want to bring those pieces back together. We need to bring the parts, the components of the ecosystem back and put them there. But then again, that's not always enough, right? We're often going to have to manage the disturbance regime because that can play a big role in determining to what extent the environment selects for native species versus non-native species, many of which are invasive. So these are kind of the three steps that we're gonna follow. So as far as the stressors go in these landscapes, things that we're going to have to remove. All right, we're going to have non-native plants to worry about, right? And one part of that are going to be, of course, agricultural crops. But then when fields are abandoned, non-native plants often take over because it's a degraded ecosystem, and so they can get there and get started. There's going to be, in some cases, fertilizer or pesticide presence. We're not going to talk a whole lot about that. Fertilizer is not necessarily a problem if the plants can take it up. But if pesticides are a serious issue, then, in the worst case scenario, soil might have to be removed if it's been pretty severely contaminated with pesticides. So have to see about that. And then drainage tiles. We talked about how those were used in wetlands. Those same drainage tiles can be used in grasslands. In some of these areas, these farmlands, they've been used so that even if it's in an area that was naturally a grassland and not a wetland, you're still able to keep the water from getting up and submerging crop root systems. So you can kind of manipulate the water table a little bit. So those are the stressors we're going to be worried about. Okay, so here's what the Nature Conservancy recommends if you're going from cropland to prairie restoration. So it's going to depend on the history of the land. And so if it's just recently been farmed and you have crop residue present, so for instance, corn stalks or something like that have been left on the land, then what they recommend is to go ahead and mow all of that down, right? So that's going to accelerate the process of decomposition. So you're breaking that residue into smaller pieces. And then they recommend lightly disking the site. So this is a disc attachment on a tractor here. And so what that's going to do is start incorporating that organic matter into the soil. And so you don't want to break up the soil more than you have to, but it's going to speed up the decomposition because it will help break that stuff up, mix it up with the soil, so those microbes and other decomposers can start turning that stuff into nutrients that can be used by our plants. Now, if it's been a longer time since it's been used for agriculture, there might not be too much crop residue to worry about. And if that's the case, you can use what's called a harrow. So this is something that, again, that is dragged behind a tractor, and it's going to create these small furrows, small scratches in the earth, which are going to help seeds to get established. So this is what's called broadcast seeding, right? So this is if you were to just kind of scatter the seeds either by hand, or there are some tractor attachments that do this as well to scatter the seed. But the seed's going to have a much better chance of being incorporated. You can speed up the process of incorporating native seeds if you scratch the surface with a harrow like this. One of the unfortunate legacies of agriculture is that soil can be quite compacted, right? The machinery that gets run over these things for so many years is very, very heavy, and so it compacts the soil to the point where there's very little airspace left in it, and so it's very hard for water to penetrate. It's very hard to have gas exchange and other things. So if that's the case, you might have to deal with that. And they recommend tilling the soil, right? So plowing that soil down to about 4 inches, so that there's enough of a loose surface to the soil where those seeds are going to be able to get established. And then once the plants really get going, their roots are going to be able to penetrate down below that. All right, so once you get to that point, you've created an environment in the top surface of the soil where those native plants can get back and do what they normally do. So then you have to put the pieces back together and bring in the seed of the native plants. So on the prairie, they use something called a native seed drill. And the way this works is that you fill it up with the different seeds that you want, and it deposits those seeds. It essentially sprays those seeds in the front of this machine, and then it goes over it. And if you can see, it's going to use those wheels to sort of work the seeds into the soil. Now you might ask, what could we be replicating with that kind of a process? Well, in fact, we're replicating the natural disturbance of herbivores on the landscape. So these grasslands would normally be subjected to herds of herbivores migrating across them, and the hooves of those herbivores would work those seeds into the soil. So the seeds wouldn't just be left on the surface of the soil in these grasslands, they'd actually be worked below into the soil. And so here at the Sneed Prairie Restoration Project, they have a little thing they do where they give all of the students a handful of native grassland seed, and they toss them onto the soil, and then they're told to stomp through them and kick their feet through them, and kick into the ground like they were bison. So the kids really love this, and it's what those seeds need, is to get worked into the soil. So it's kind of a neat way to to try and replicate native herbivores, and have a lot of fun with the kids as well. All right, so if you think most of these native grasses are producing seed in pretty hot conditions. So you want to do it when the temperature is relatively warm. Spring is generally best, and you can buy mixes of native grass seeds. You can order these online. You can get mixes of all different species. And so the things to think about: what species you want to use and how much how much to use. A couple of things to think about is that, first of all, if you're going to be using this area for livestock, because you can graze cattle on these lands, then you want to make sure you have a mix of palatable species. You're going to want to mix species that have different niches, right? Different warm and cool temperature species, so that some are going to survive no matter what the weather looks like, especially early on as they're starting to grow. And like any restoration project, you want to find seeds of species that are native in your area. And I think I mentioned the other day, it's kind of interesting that big blue stem, this tallgrass prairie species, is also found in our neck of the woods. So some of these species are pretty widespread. If you're going to be seeding sloping areas, then be sure to use species that are going to spread pretty rapidly and are going to help to hold that soil together. And on steep slopes, you're going to want to plant at an even higher density, because one thing you don't want to have is bare soil left to be erodible once you get wind and rain coming through. And if you don't have a native seed drill, you can use something like this piece of equipment called a cultipacker here. Again, it's something that attaches to the back of a tractor, and so it'll go over those seeds and work them into the soil, and that's going to stimulate germination and provide conditions that these seeds would normally experience to allow them to germinate and get going. All right, so if we've got our grasses back there, and we've planted them, and so then the final part again is to create conditions that are going to favor those native grassland species, and so then you're going to have to manage this disturbance regime in some way. So that can be challenging, right? Because we don't have bison roaming the prairie anymore. We have cattle, and bison and cattle differ in the way that they graze. Bison are generally more selective. Cattle will graze grasses right down to the nub. Although there's been some debate in the literature, some folks argue that the only reason that bison are more selective is because they range over larger areas, and so they can afford to be selective when they've got large ranges to move through. Some folks say, well, if cattle have more room to spread out, they will also feed more selectively, because the problem you can have with cattle is that they can graze the grass right down to the nubs, and that can actually kill it. And when that happens, then you don't have the grass to hold the soil together. That can be a problem. At the Sneed Prairie Restoration Project, they actually had a gentleman who would bring bison in once a year on a big trailer, and they would just kind of let them roam for a while and graze. I forget how long it was for, but they were really trying to kind of replicate the natural disturbance regime as best they could. So that's a big piece. So, as much as the kids tromping through the grass were replicating maybe a little bit the hooves of these bison, certainly, this wasn't in any way, doing anything to replicate the foraging. So that was why you had to actually bring the bison in for that particular part. All right. So the other thing, people have worked really hard to reduce the frequency of fire in our ecosystems, especially ecosystems where there are houses nearby and property. So these ecosystems aren't allowed to burn the way that they used to. So what you have to do now is carry out what are called prescribed burns. And so these are exciting and kind of a big deal. Everybody always wants to volunteer for them when they're going on. And you use what's called a drip torch. The student volunteer on the right is carrying one. It drips kerosene and has a little flame, and so you can move it along and create a line of fire. And you want to use the right wind conditions and everything else. It's a very controlled process now because you don't want it to take over. But these prescribed burns are a big part of managing a lot of terrestrial ecosystems, not just grasslands. But again, this kind of burning is going to affect woody species that aren't adapted for fire in a very extreme way, and so it's not going to allow species that aren't adapted to fire to get in there and persist, right? Whereas these native grasses again are adapted for this just fine, so they'll come right back. Okay, so here's what's recommended for management after you come in and seed these prairies. So in the first year, it's recommended to mow to keep any annual weeds from taking over. Right? So you don't want these weeds, these fast-growing annual species, to get in and shade out the perennial grasses. So you want to mow and kind of keep it a level playing field, so to speak. Second year again, mow to about 12 inches or so. Again, that's just kind of, if there's still some annual weeds that are taken over, and if you see any patches where annual weeds have been doing very well, then you can mow those to a lower height again to give those perennial grasses a leg up, so to speak. And then about year 3 is when they say that there's going to be sufficient biomass for a burn, and that might depend on the weather in the last few years. But you don't want to burn when these perennial species are still getting established and don't maybe have the root systems and everything intact yet to make it through. But as soon as they do, that's when you want to start doing these prescribed burns. And then that is the way that you're able to keep these non-native annual weeds out of the way. And then again, year 4 on, it's recommended every 3 to 5 years burning, and I sort of mentioned why already. So that makes it harder for any weeds, including some perennial weeds, right? So these annual weeds, once the perennial grasses are really established, these grasslands are so dense, it's hard for annual weeds to get in there and do well. I mean, they just can't grow. But you can have some perennial weeds, some perennial species you don't want in there, but they're not going to be able to do well in that fire regime. And the final piece again, right, is that woody trees and shrubs they're not going to do well at all when there's a fire regime. So that's gonna play a role. And the final thing to mention there is that burning like this is a way to get nutrients into the soil really rapidly, right? Again, it takes that above ground biomass, breaks it down so it can get incorporated into the soil. And so that stimulates a productivity, right? So again, we're going to be stimulating the movement of nutrients from above to below ground, and also create patches of that that new grass growing up that's very attractive to grazers.